So exercise 12C-3 is using recursion to generate a state matrices step by step. Okay, now that makes probably no sense to you guys of what's actually happening there. So let's just go through it very quickly. Okay, so what is a state matrix? A state matrix is one, it's called a steady state. Steady state matrix. Now what that means is where the matrix that when we work it out, say after 15 times or 20 times or 100 times, and we check then the next one, 101, if we do it 100 times, or if we do it 50, we're checking 50 and 51, that it remains the same. That's what steady state means, remains the same. So the matrix will never change, okay? Now, we can do it using like a recurrence relation, okay, which is a step-by-step one. So we find the first one, okay, by doing this transition matrix times the initial thing, get the S1, then transition matrix times the S1 to get the next one, then using that one there, S2 times the transition to get S3, and so on and so on and so on. Okay, it would be there forever if we do it like that when we have to do a steady state. But let me show you an example of doing it. Example 1. It says the factory has a large number of machines. The machines can be in one of two states, operating, which is O, or broken, B. Broken machines are repaired and come back into operation, and vice versa. At the start, 80 machines are operating and 20 are broken. So there's our O and there's our B, and S of 0 is always the initial, the state, okay, when we're starting, initial value. And there's the rule that they want us to use, which we can see is like the recursion stuff. They've said use the recurrence relation below to determine the number of operational and broken machines after 1 day and after 3 days. Okay, so we're going to do S of 1 over here. S of 1 is going to be T times S of 0, just like we did with recurrence relation. So it's going to be 0.85, 0.15, 0.05, and 0.95, and we're going to multiply it by the original, S of 0, which is 80 and 20. And when I do that, I haven't done it, I've got to do that. Okay. The answer is S of 1 gives me 69 and 31. That's S of 1. They also want S of 3, okay, after 3 days. Okay, now to get after 3 days, we have to do S of 2. So I'm going to do S of 2 down here in the corner. S of 2 is going to be T times S of 1. I have to do this, doing it this way. So I'm going to have 0.85, 0.05, 0.15, 0.95, and then times S of 1, which is 69 and 31. Okay. And when I do that, it gives me 60.2 and 39.8. 60.2 and 39.8. Don't round into your final answer because we really don't care about that when we want S of 3, which is T times S of 2, which means I'm going to do the 0.85, the 0.15, the 0.05, the 0.95 times S of 2, which is 60.2 and 39.8, which will give me, I'm just going to write it above here, 53.16 and 46.84. So you can't write that because how can you have 53.16 machines that are operating and 46.84 machines that are not operating? So we round, okay? So we'll have day 3, I didn't write day 1, but day 3 we'll have 53 operating and 47 broken machines. Day one was quite simple, 69 operating and 31 broken. Any questions on that one? I'll wait for you guys to copy it down anyway. Okay, let me clear this. Okay, now instead of doing it that way, we can do it using this rule. S of n equals t to the power of n times s of 0. Okay, this is rule, because look, if we did the S1, we see we did the t times s of 0. Then S2, we did t again times s of 1. Then S3, we did t again times s of 2. So really, this is what we're doing. So we can change this rule to do this. T will always be the transition matrix, and s of 0 will always be that initial state, the original that they give us. So that's what we're going to use from now on. So to clear it, I'll clear it in a minute. Okay, example 2. Let me clear that. So the factory has a large number of machines. The machines can be in one of two states, operating or broken machines. Broken machines are repaired and come back into operation, and vice versa. At the start, 80 machines are operating and 20 are broken. There they are. There's the original. Okay. We can do this transition matrix. I'm going to do it with you. There are, I know they didn't give us the transition matrix, so I can't do that with you. So they've given it to us already set. Determine the number of operational and broken machines after 10 days. So really what we're going to do is this, S of 10. 10 days, that's what we want. We're going to do the T to the power of 10 times S of 0. That's using the rule in the box up here. So really, we're going to get the transition, there it is there, 0.05, 0.95 to the power of 10, and we're going to times it by the original, 80 and 20. So I want you to all do that in your calculator. You don't need to do it like this. You can do it as one hit, exactly like I have written it in red. Okay, you will still get that. There's no need to save it, save it to T, save it to S like here. You can just type it in. But you should get these answers. Okay, so everyone try it. I'm going to give you a minute, and then we'll just finish it off in theory, writing it down in theory. I'm going to do mine as well. By the time I finish it, you guys should have finished it already. Okay, and that's what we get. So now finishing it off. So determine the number of operational and broken. There would be 31 machines operating, and there would be 69 machines broken. And if you add those two numbers up, 39 and 61, you get 100. And if you add the original amount up, 80 and 20, you get 100. Okay, you are supposed to get the same amount because there's always 100 machines. 80 at the start that are operating and 20 at the start that are broken. If you get a different amount here, if this adds to 101, you need to remove a number, okay? You need to remove one machine. That's very, very important. All right, I'll clear this. Move on to the next one. Example 3. Says, a survey shows that 75% of the time customers will continue to purchase their groceries from store A if they purchase their groceries from store A. So 75%, store A, store A. While 25% of the time consumers will change to purchasing their groceries from store B if they purchase their groceries from store A in the previous month. Similarly, the records show that 80% of the time consumers will continue to purchase their groceries from store B if they purchased them from store B in the previous month. Okay, how many customers are still purchasing their groceries from A and B at the end of 2 months? So 300 customers started at A and 300 started at B. So there is our original, S of 0. 300 started at A and 300 at B. And the SO will always look like this matrix. Never on the side, it's always a column matrix. Now we're going to work out our T. Okay. We have store A, store B, store A, store B. This month, next month, just so we can see it. Okay. The first one says 75% of the time customers will continue to purchase their groceries from store A if they purchased it from store A. So store A this month and store A next month, 75%, 0.75. If there's any questions, please jump in. The next part, it says 25% of the time the customers will change to purchasing their groceries from store B if they purchased their groceries from store A. So they're going to change to store B if they went to store A first. So month A, this month, store, next month, store B, 25%. And you can see it adds up to 1. That is what we wanted. I'll raise all this over here. The other part says, similarly, the records show 80% of the time they will continue to purchase from store B if they purchase it from store B. So store B this month, store B next month, 80%. Which means over here I must have 0.2 even without reading it, because again it has to add up to 1. So we've done our transition matrix. Any questions there? Okay, so going back to the question, it says how many customers are still purchasing their groceries from A and B at the end of 2 months? So we want S of 2, 2 months later. So all we're going to do, and I'll do it here, T2 times S of 0, 2 months later. So 0.75, 0.25, 0.2, 0.8 to the power of 2. I better put the zeros there only to keep them consistent, because 0.75, 0.25 is 2 decimal places. So I'm going to keep the 0.2 and the 0.8 as 2 decimal places, only for consistency in your SAC and the exam, really. Oops, that's not my my SO. My SO is 300 and 300 in store A and store B to start off with. So let's do that one. What do we do? Matrix. Oops, that one there. 0.75 tab, 0.2 tab, 0.25 tab, 0.8 tab, power of 2, right arrow times, and we've got this one here, 300 and 300. 300 Okay, I get, when I do it, 276.75, 276.75, and 323.25. Now remember, I can't have any more than 600 because 300 and 300 adds up to 600. Okay, so I'm going to put this one here, 277, and that's 0.75, and I'm going to put this one to 323. And I'm going to check that. Okay, that's going to be my answers. 277 plus 233. Sorry, 333. 277 plus 333. 323. 600. Beautiful. That gives me 600. So now I can say at the end of 2 months, and remember, write this down and then round off. 2 months, store A will have 277 customers, store B will have 323 customers. Okay, any questions on that one? Let me clear this one. Okay, part B. What percentage in whole numbers of customers are purchasing their groceries at A and B at the end of 6 months? If 50% of the customers started at A. Well, we know there's 50% of customers starting at A because S of 0 is 300 and 300. So 300 out of 600, 0.5, 50%. Okay, but now we want it after 6 months. So we're going to go S of 6, and we're going to get this amount, S of 6, which was 0.75, 0.25, 0.2, 0.8, power of 6 times 300, 300. You first need to work this out. So, okay. Press up arrow to get to the original where I've already worked that one out. Change that power of 2 to the power of 6. Right, I get 267.59 to 2 decimal places and 332.41 to 2 decimal places, which I'm going to round. And all we really want is A. This is A, 267.59, so 268, but we want it as a percentage, 268 out of 600, because that was the original, and we're going to times it by 100%. So 268 divided by 600, times it by 100, I get 44.67, how many whole number? So 44.67%, which means 45%. Okay, rounding to the nearest whole number. 45%. Any questions on that one? Okay, I'll undo this one. Okay, now here's a steady state. As I said, the steady state is when that matrix, that T matrix, or our answer stays the same. Sorry, not the T, where our answer stays the same. Okay, it will be steady. It will not move. Okay, generally we try 50, but when we're doing a steady state, we can't only do one matrix. So if we try 50, then we also have to try n equals 51. And we have to get these two answers the same, okay? The answers have to be the same. Very important. So you must, if it doesn't work for 50, you might try 55, S of 55, and then you have to try S of 56. They have to get the same answers, okay? Just not one will not do. You have to show both of them and say then that it's a steady state. Very important. Clear that. Okay, example 4. So the car rental firm has 2 branches, one in Bendigo and one in Colac. Cars are usually rented and returned in the same town. However, a small percentage of cars rented in Bendigo each week are returned in Colac and vice versa. Diagram below describes what's happening on a weekly basis. 50 cars in Bendigo and 40 cars in Colac at the start. So there's our S of 0. S of 0, 50 and 40. This is Bendigo, this is Colac. Okay, set up a transition matrix. Okay, let's do that transition matrix straight away. We're going to go Bendigo, Colac. Okay, Bendigo, Colac, because I've set it as Bendigo first. So Bendigo to Bendigo, 80%. Bendigo to Colac, Bendigo to Colac, 20%. And I should know that because it adds to 1. Colac to Colac, 90. So Colac to Colac is down here, that's 90. So this one must be 0.1. Okay, you can do the 2 decimal places if you want. It doesn't really matter. That's not going to do anything. The second one, set up the initial state matrix. So I've already set it up up the top, but S of 0, 50 and 40. Okay, remember this was Bendigo, this is Colac. Part C, how many cars will be available for rent at Bendigo and Colac next week? Now remember, this is a week-to-week basis. So we only need to find 1 week. So let me just go a little bit higher. I can't really go higher. I'm going to have to clear it. Anyway, I'll try and squeeze it in there. Okay, so we're going to do S of 1. Really, we're just going to do T to the power of 1. I don't really need to do that, times S of 0. Okay, so our T, 0.80, 0.20, 0.10, 0.90 times 50 and 40. Okay, what do I get? Okay, I get 44 and 46. Hopefully you guys got the same thing. 44, 46. So Bendigo, 44 cars, and Colac, 40 cars. And you can see 44 and 46, sorry, 46 has to add up to 90. 44 and 46 adds up to 90. All right, any questions there? Okay, let me clear that one and move to the next part. D, how many cars will be available for rent at Bendigo and Colac after 2 weeks? Okay, well, after 2 weeks, we're working out S of 2. And I'm going to just do T squared times S of 0 because that's the easiest way. So 0.8, 0.2, 0.1, 0.9 squared, 50, 40 was the original. Okay, my calculator. Power squared. Okay, I get 39.8 and 50.2, which of course I'm going to say Bendigo, 40 cars, and Colac, because I'm going to round that one, 50 cars. And again, it still adds up to 90. Any questions so far? Okay, part E says estimate the steady state solution for calculating 10, 15, 17 and 18. Okay, I'm not going to do all those. Okay, I'm going to say to you that the steady state, I'm going to work it out by showing you. S of 15 going to be t to the power of 15 times s of 0. Now I'm just going to write the answers here. I'm just going to work it out on my calculator, but remember we're doing this to the power of 15 times s of 0. And then I'm going to do 17 and 18, so I'll change it to 17 and change that power to 18. That's all I'm doing on the calculator. So up arrow, enter, change the 2, which is a squared button, to a 15, enter. So I get s, what? I get s of 15 is 30.09 and 59.905. Now I'm going to do s of 17 just to show you that there is a difference. I know I'm not doing 16. So 17 times s of 0. So I'll turn that to 17. If there's changing at 17, that means most likely there will be a change at 16. So this answer is 30.0459.95. And now I'm going to do s of 18, which is t to the power of 18 times s of 0. 18. And I get 30.03 and 59.96. So it's still changing. Okay, it's still changing. So let's do s of 19. Okay. It should remain the same. I mean, instead of doing all this, 50 would be the easiest one. Okay, and you get 30.0 again and 59.9 again. So there it looks like, that's what it looks like. It's going to be 30 in A, not in Bendigo, and it's 60 in Colac, because you can see 59.95, 59.96, they're all 59.9. So that's what we're going to get, okay? That's how we're going to get 30 cars in Bendigo and 60 cars in Colac, and that's called the steady state. It's not changing. We're not changing to 31 in Bendigo or 29 or 61 in Colac or 59. It's maintaining, okay? Any questions there? Okay, I'll clear this. I think that's the last one. All right, example 5. Okay, example 5. It says, imagine we live in a world in which people are either happy or unhappy. However, the way people feel changes from day to day. In the imagined world, okay, there it all is. There, construct a transition matrix. So 90% of people are happy today and will be happy tomorrow. Happy today, happy tomorrow, 0.9. I'm just going to give myself a bit more room. Tomorrow, happy, unhappy, happy, unhappy. Happy today, happy tomorrow, 0.9. This means it's 0.1 without even reading it, but there it is there. 40% of people are unhappy today and will be happy tomorrow. Unhappy and happy, 0.4, which means that's 0.6. There they both are. Okay, I've got my 1 and 1, so I'm happy. On a given day, out of 2,000 people, 15 are happy, 500 unhappy. Write down a column matrix S0 that describes that situation. So S of 0, happy is first. Happy is 1,500. Unhappy is 500. Has to be happy first because I wrote happy first here. Okay. The next day, how many people do we expect to be happy and unhappy? So we want 1 day later. So S of 1. T times S of 0. So 0.9, 0.1, 0.4, 0.6 times 1,500, 500. Okay, let me do that. .9 tab, 0.4 tab, 0.1 tab, 0.6 tab times 1,500, 500. Okay, I get 1,550 and 450. So happy, 1,550 people, unhappy, 500 people. Any questions? Okay, let me clear that. D, after 4 days, how many people do we expect to be happy and unhappy? Okay, 4 days. So I'm doing S of 4. T to the power of 4 times S of 0. I'm just going to write that, of course, and for the sake, I would write it in matrix form like above. To the power of 4, enter, and I get 1593.75 and 406.25, which means happy, remember we have to round, 1594, unhappy, 406, and if you add them up, it still gives you 2,000 people. And then part E says, in the long term, how many would we expect to be happy and unhappy? Okay, I'm going to try S of 50 and S of 51. Okay, so T to the power of 50 times the original gives me 1,600 and 400. And now I'm going to check T to the power of 51 and times the original, and hopefully I get the same answer. I get 1,600 and 400. So great. In the long term, steady state, in long term, expect 1,600 people to be happy and 400 people to be unhappy. All right, any questions there?